we'll just look at data cleaning in Python briefly before we go into the hands-on, so that in the hands-on, we will look at a few of these operations. So mainly, if you are talking about data cleaning, you are talking about identifying and correcting inaccurate or inconsistent data in a data set. What this mainly means is if you are going to use machine learning algorithms, from the explanation we had in one of the first classes, machine learning is a process where you develop a model or algorithm or a system that can learn from previous experiences. Now, how do you represent these experiences in terms of artificial intelligence? You represent it in form of data. Now, that data isn't always perfect. You are going to have some errors in the data, some inconsistencies. The data might be arranged or presented in a format that is not suitable for your machine learning algorithm. So it is left for you to handle. It's left for you to handle these problems so that the data will be suitable for your application, and also so that your model will be accurate. So the process of this cleaning and correction is referred to as data cleaning. Now, we have some steps in data cleaning. This is not an exhaustive list, but these are some of the most common things that you would encounter, or that some of the common things you would have to do when dealing with data cleaning algorithms. The first one is you have to handle missing values, because sometimes your data would come with missing values. The second one is you have to handle duplicates, because there will be instances where the data is duplicated, maybe in situations where sometimes you're supposed to fill a form online and you fill it and you press submit, and on your part it shows that, okay, maybe it didn't go through, or after the page loads it becomes blank and you're not sure whether it went through or not. So you decide to reload the page and re-input the data. Maybe the data has already been logged there. So in that kind of situation, you'll be having duplicates of the same data, which would not help your model. So you have to handle that as well. You have to handle what we call outliers. Now, what outliers stand for is if you have a data range that is outside what you want it to be, then you have to handle these out. Those are what you call outliers. For instance, if you are looking at data that involves teenagers, you know that, okay, you are considering the ages of, let's say, between 13 and 19. So when you start having ages of 24, 25, or 12, or maybe 7, you know that, okay, these elements are not supposed to be in your data. They are outliers, so you need to remove them as well. Then you also have what is called inconsistent data. For instance, you have a data that is in a particular format, but then later on, as you go down the data, as you scroll down, you see that same information is represented in a different format. For instance, if you are representing date and you have January written in words, then you go down and you see January in number, then the data is not consistent. So you need to make it consistent. Then you also can transform the data. If it's not in the format that you want, you have to turn it into a format that is suitable for the machine learning algorithm. There's also data validation, where you have to just make sure that the data is what you expect it to be. Then you also have data standardization. So we'll look at these one after the other briefly before we go into the hands-on. Are you still with me? Can you still hear me?
Yes, sir.
Okay, thank you. So let's look at handling missing values. Now, like I said, sometimes you would have data that some parts of it will be missing. You have some elements that will not be there. Some would be there, but there would be, there's this value that is called NaN, N-A-N. Usually it stands for not a number. And usually that occurs when you have a value that goes to, let's say, infinity, or you divide by 0, or you have a value that is too high to be represented in that data format. So when you have elements like that, especially data that is computed automatically and saved, you possibly have elements like this. So you have to find a way to address these kind of data. Now, how can you do that? There are several ways that you can handle missing values. The first one is to drop the missing values. Maybe if an element of the data is missing on that row, and it's very important to your computation, you can drop the row completely. Usually, if you have thousands of elements in the data, maybe you're considering thousands of students, it's a student data, and maybe, let's say 10, you have 10 that have elements that are missing, you can drop those 10 students' records because compared to the thousands that you have, that 10 is a bit insignificant. Then you can also impute missing values. What that means is you can put some values there. Maybe if you look at the range of the elements there, you can maybe take the mean of those of the other elements in that column and input it there just to serve as, you know, a filler, more or less. Then you can also fill it with maybe the median or the mode or anything that you want to do. Here they said using pandas. Pandas is a library in Python that is used mostly for numerical computations and data manipulation. So we'll look at that later. You can also interpolate missing values. For instance, if you have two data values that are between 80 and 100, you can interpolate and maybe get a value of 90 or 87 to put into that value, depending on the distribution and the data range. Then you can also use other machine learning algorithms to predict these missing values. So, but it all depends on the kind of method that you want to choose, what you want to do, and the amount of missing values. Like I said, if your data is in the thousands and you have 10 missing values, then you can drop those 10. It doesn't significantly affect your data. But however, if you have a data in, let's say that is, maybe you have 100, and you have 10 missing values out of 100, that's about 10%, and that is significant, very significant. So you do not drop in that case. You have to find another way to fill in those data values. Now, you can also handle duplicates. For handling duplicates, you are mainly identifying and removing duplicate records. So like I explained earlier, if you have data that is duplicated, you can remove the duplicate. Now, what I mean by duplicate is if your data has one person, right, that has age, gender, date of birth, and everything. If maybe person A is 19, and the next person after him, person B, is also 19 in terms of age, that is not duplicate data. It's just a coincidence that two of them have the same age. What I mean by duplicate is person A has age 19, date of birth this, gender male, and all that. But you also have the same data of that person A with those exact same values. That's what you mean by duplicate data. It's not that if one person is 19 and three other people are 19, you consider all of those duplicates. No, the entire data record, that entire row, needs to be replicated exactly for it to become a duplicate data. So normally what you do is you identify the duplicates. There's a pandas feature for that. Then you drop the duplicates. You can remove them in this case, because if you have duplicates data, they will lead to what is called overfitting. Your data would not perform, your model will not perform properly. And in that kind of situation, the duplicates are useless. So if you have duplicates, you remove them. Then we talked about handling outliers. More or less, you have a data set and you have elements that are outside the normal distribution. So you can remove them. If it's very small compared to the data set, you can remove that row like you did with the missing values, or you can clip them. Clipping means if you have a value, if your values range, let's say, like I talked about the teenagers, you have age values that range from 13 to 19. You could clip it in such a way that any model, any number above 19 should be just assigned the number of 19. Then any number below 13 should be assigned the number of 13. So what you are doing is you are clipping, making sure that anything above the upper range should be clipped as the upper range, and anything below the lower range should be clipped as the lower range. Then you can also bin. Bin means if you look at the range, instead of using the maximum or minimum values like clipping, you can just take the mean or the median of those values and input it there. Then predictive modeling also, you can use machine learning algorithms to input those data that are missing. We talked about it in our first class. We called it semi-supervised learning, where you have some elements of the data that are missing, and you're using the machine learning algorithm to complete those elements that are missing. Then you also have inconsistent data. For inconsistent data, you're converting it to a text. So, to a particular format. So if you have all text, for instance, that are in uppercase, then you can convert all the other ones that are in lowercase back to uppercase. Or maybe if you have data types, maybe if you're dealing with integers and you have a float, you can convert everything back to integers. So more or less what you're doing is you have to cross-check. Sometimes these things have to be done manually so that you can look at the inconsistency and correct them before you use the data. Then you can also transform the data. More or less what transformation stands for is if you have a data that is biased to a particular side, then your model would tend to lean more towards that biased data. What do I mean? For instance, if you're developing an object detection model and you want to detect 3 types of fruits, mango, banana, and apple. If you have more data for mango and less data for banana and apple, then your model will have a higher accuracy for mango and lower accuracies for banana and apple. And you don't want that. You want your model to have a consistent accuracy across all classes. So in that kind of situation, you have to make sure that your data is skewed. That means the distribution is normal. You call it class imbalance, where you have more data representing a particular class than another. So you have to make sure that the data is balanced all through the classes. So you have the log transformation that you can use the np.log function. You have clipping as well, usually with outliers. You can use different scales. Like you have the min-max scaler, where you take the minimum and the maximum values and you scale them based on that, based on the range. You have the standard scaler, which gives you a value between 0 and 1. All your values will now fall within 0 and 1. Then you also have the robust scaler, which works based on a particular equation or a custom function that you want to scale based on that. So each of them serve different purposes. Then in data validation, mostly this involves you checking your data to make sure it's exactly the way you want it to. So in this case, you check the integer, whether they're in the right data type, you check the value range, make sure that they're in the proper range. Sometimes you have to check the spelling to make sure that the words are spelled properly, because your AI algorithm will see M-A-L-E and maybe M-L-E as different things entirely. Maybe some people, when filling a form, when they get to gender, they will represent male as M-A-L-E. You have another set of people who would represent it as just M, who just put M. Then some people, when inputting the dates, they'll put different date formats. And that's why sometimes when you're filling forms online, they specify that this is the type of format that they want you to put the data for, or they just create drop boxes that you select so that they know that any data coming in is consistent. Then you have to also check that there are some checks that you need to do that are not based on the presentation of the data, but based on the content of the data. For instance, right? Hello, can you hear me?
Yes, sir.
Yes, sir.
Okay. Can you still see my screen? Okay, okay.
Yes, sir.
So for the data validation, sometimes you have to check for consistency. About people maybe who have passed away, and you have the birth date and you have the death date. Then you have to make sure that birth date is before death date. Some people, when filling the form, maybe they make a mistake and put one before the other. So you see, in that case, that data is not proper. Or if you're talking about the parents.
Sir, we cannot see your slide again, sir.
Oh, okay. So let me reshare. Can you see it now?
Yes, sir.
Okay. So sometimes if you are talking about a date of birth of parents and the child, you cannot have a child who is older than his father or mother. So you have to check that those dates are consistent. Then the last thing that I want us to look at is the data standardization. Sometimes you have standard formats that the data needs to be represented as. So the two most popular ones are the Z-score standardization and the min-max normalization. With Z-score, you have a particular equation that normalizes the data, while the min-max, it just distributes the data between the minimum and maximum ranges. So these are some of the things you do in data cleaning. So most of the times, if you're developing machine learning algorithms, it's not just about getting the data, but it also involves you, what are they calling it? It also involves you making sure that the data is proper and the data is exactly the way that you want it to be. So that's where we will stop regarding the presentation. So let's work on the hands-on. I think we should work on the hands-on so that you can see the examples of some of these things that I've been talking about. Just give me a few minutes. Let me get some things in order.
It seems the facilitator is having network issue. Based on what he has said, if we have any question, you can bring the question now, and also I will share the link of where you can see you see all the past class we've done. Yeah, you will see that on the in-code charge now. Thank you very much. Okay, it's back now. Over to you, sir.
Hear me now? Hello?
We are with you, sir.
Okay. So what I want to do now is I just want to demonstrate some of these things that we talked about on data cleaning, just a few of them. We can't cover everything, but I just want us to cover a few so that we would be familiar with, what are they calling it, with some of these processes. There are a lot of data cleaning operations, but I just want to give you a sense of what you need to do. Usually, one of the first things you do is you download the data set. Now, depending on what kind of application you want to use it for, that will determine the kind of data set that you are going to download. If you want to do object detection with images primarily, then in that kind of situation, you have to get an image data set. You have to get images. Now, if it's about images, more or less, you don't have to worry about the values or how numbers are inputted or whether there's a mistake in something or not. The main thing that you need to worry about is, okay, all the images should be balanced. If I'm considering mango, apple, banana, then they should be the same number of images for mango, apple, and banana. But there are instances that, okay, you're not considering images, you are considering numerical data. Maybe you want to predict weather. Maybe you want to predict the stock market. Maybe you want to even predict diseases like we'll see today. I have a data set on diabetes. So in that kind of situation, you have to look at the elements and understand what it means. So before I go into even the coding, let me open one of the data sets. Let me open that of diabetes so that we can see the data. We're always talking about data. So let me open one of the data sets and let us see what it looks like. So let me reshare. Okay. So if you can see my screen, I think it's coming up. Okay, good. If you can see my screen, you would see a data set, and this data set is for diabetes. It's from a popular machine learning tool called Weka. This is from what they call the Pima Indians data set. Now, this data set has about, let's see. Okay, it has about 769 elements of the data. So it is quite small, actually. Usually we want data in the thousands. But what it has is it has 1, 2, 3, 4, 5, 6, 7, 8. It has 8 columns of different fields. Excuse me. It has 8 columns of different fields that you can look at for a person, and it has a class. So what this means is if you look at this field that has been highlighted, it belongs to one person. So each row represents one element. It represents one person. Then each column represents a field, one field for all the elements. So a row in our student case might be a student information, age, class, gender, date of birth, and so on. But a column might be age for all the students. So for this data set, what you have is the first column is number of times. So this data set actually is a data set of people who have and who do not have diabetes. So they got a data set of 769 people. And if the person has diabetes, the class of the person is 1. If the person does not have diabetes, the class of the person is 0. That's what this column of class represents. Now, for one person, the data they have for the person is this A that looks that is preg means how many times has the person been pregnant. So like for this first person here, the person has been pregnant 6 times. Then you also have the plasma level in the blood, and the value of the plasma level for that person is 148. Then this is the, I think, diastolic blood pressure, and the value for that person is 72. There's a skin factor that they measure, and for the person is 35. The insulin level in this case is 0, and the body mass index is 33.6, and you have a pedigree factor of 0.6 and the age of 50. So with these parameters, the person has diabetes. This is a real person. Then if you look at the second person, all these parameters as well, but at the end of the day, the person does not have diabetes. So this data was collected. So what you can do with this data actually is you can feed in this data into a machine learning model, maybe artificial neural networks, support vector machines, logistic regression, or any classification model. And when you feed this, this is supervised learning because you have the classes that tell the model, okay, this information represents this class. And when you feed this into a model, the model will now learn from this data. It will find a relationship between all of these plenty values that you are seeing, such that if you bring another person that is not part of this data at all, and you feed in these 8 values, the model can now predict which class the person might belong to. So you can use this to predict if a person has diabetes or not based on this information. So maybe if you are thinking of developing medical systems for diagnosis or prediction of diseases, you have the first set of, you can use it as a first level of diagnosis where the person can input values for the machine learning algorithm, and the algorithm can predict if the person has that disease or not and recommend if the person can go for further checkup. So this is for diabetes. So let's look at another data set that I have. Okay, so let me reshare my screen. This is an employees data set. So what you have is just employee information for this data set. And you have the first name, you have the gender, you have the start date, the last login time, the salary, the bonus, and this is senior what? Senior, if the person is part of senior management or not, and what team the person belongs to. So this is also, you can also use this in machine learning. Maybe if you want to predict what kind of bonus the person can get based on this information, or just maybe analyze it and kind of see the productivity of some people as regards to others, or what department performs better in what kind of situation. So these are some of the data you might have. So as you can see, this one, it is not numerical like the other one. You actually have strings, like the name, they're in letters, the gender is in letters, the dates are in date format, the login time is in the time format, the salary is what is numerical, and the bonus. So here you have a mixture of different data types. So in this case, you have to go through, like if you scroll down the data now, we can see that number 22 has missing gender. Number 24 has missing gender. Number 25 has a missing first name. Number 27 has a missing first name. So your data might come in like this. This has a missing management, whether the person is in senior management or not. So you will have data like this, that you have many missing things. And this data is in, let's see, it's 1001. So if you look at the elements that are missing, you can decide whether you want to drop them or you want to replace them with something else. So let's go to the hands-on now and see some of the basic operations that we can do. Are you guys still with me? Okay.
Yes, we are.
Okay. So for the hands-on, I am using Visual Studio Code. During the introduction, I don't know if this was mentioned, but you have different tools that you can use for machine learning, coding, and Python programming. For these sessions that we are having, we are going to be using Python, and later on we're going to use MATLAB as well. But for Python, you can use the Python IDE that comes with the Python installation. You can use Visual Studio Code. You can use Jupyter Notebook. You can use Google Colab. So I'm using Visual Studio Code. It's basically, irrespective of the tool you are using, it's more or less the same code that you are going to be inputting, but it's just the interface that's going to be different depending on what you want to do. So let me create a new notebook. So I'm going to File, I'm going to create a new file. Then I have a text, I have the option for text file, I have the option for Python file, and I also have the option for Jupyter Notebook. If I select Python file, it means that I have to type in all my code before I run it. That means I type in all the codes that I want to type on my file, and then I click run, and it runs everything together. But that's not what I want to use. For those of us that are familiar with programming, we know that a lot of times that's how you do the programming. You write everything on a file, and then you run the file. That's not what I want to do in this case. I want to run it step by step. So in that kind of situation, Jupyter Notebook would give me a better support, since I can run it, usually with the notebook, you run it cell by cell. You can also run the entire cell all together, but you can also run it one by one so that you can see which element of your code results in what. So I've opened the Jupyter Notebook. If you cannot see my screen, I think from your Google Meet, you can zoom in and look at what I'm typing. If you're on your phone, you can zoom in with your phone. And if you're on your laptop, you shouldn't have any issue because the screen should be wide enough for you to accommodate that. So one of the first things that I would want to do in this case is for Python, you deal with Python libraries. So you can do basic operations in Python, but you also have libraries. What these libraries do is they give you additional features to the Python code so that you can use these features of the library that you can use. Now, one of the libraries that we are going to be using is called Pandas. Pandas is used mostly for data manipulation. Then we are going to use another library called NumPy, and NumPy is mostly used for array manipulation and matrices. So how you do that is you type import, meaning you want to import the library into your current workspace, then import Pandas. Then I can also type import NumPy. Now I'm going to add two more things to Pandas and to NumPy. The first thing I'm going to add is, if you import Pandas, there's a concept called object-oriented programming. And in object-oriented programming, well, the concept is quite tricky to understand, but let me see if I can break it down into a way that is easy for us to understand. If you want to interact with Summit University, maybe you want to talk to Summit University, how do you talk to Summit University? You talk to a representative of Summit University. So maybe or you talk to the BOSA, or you talk to any of the students of Summit University. Are you still with me?
Yes, sir.
Okay, so if you want to talk to Summit University, you talk to a registrar, you talk to a BOSA, or you talk to any student from Summit University. That's the person you talk to. You do not talk to the university directly. You do not talk to the university directly. You talk to somebody from the university. So it's the same thing with, what are they calling it? It's the same thing with object-oriented programming. In object-oriented programming, you use what are called classes, but you don't use the classes directly. You use representations of those classes. And those representations are called instances of the classes or objects. That's the explanation I think that's the basic explanation that I can give you for object-oriented programming. So in this case now, I'm importing a library called pandas, and I'm importing another library called NumPy. So think of pandas and NumPy as our entire university. I don't want to use the entire university, so I want to use a representative of that university, in this case, our instances of those libraries or classes. So how do I create the instances? All I do is I say import pandas as, let me call the pandas instance PD, and let me call the NumPy instance NP. Now what I've done here is anytime I want to use pandas or I want to use NumPy, I can use PD, I can use NP. Now I'm going to Hello, can you hear me?
Yes, sir, we can hear you, sir.
Okay. So I've declared these elements of these libraries so that I can use them directly and I can run the code in Jupyter. Like I said, with Jupyter, it runs it block by block. So it will give you a tick indicating that it has finished running. Now, some of you might, if you try this at home, you might run into problems using any of these libraries, because before you use the libraries, you have to import or install the libraries on your Python. So if you're using Visual Studio Code, Jupyter Notebook, the Python IDE, you have to install those notebooks on what are they calling it? On your Python instance or whatever you're using. So I'm going to type something in the chat box so that you can use that to install. Usually if you want to install the library, you can write pip install pandas or pip install NumPy. Now, if you are using Anaconda is another tool for Python programming. You can use, instead of pip, you can use conda install pandas or conda install NumPy. So you can try these. I think this is the correct syntax, but in case it doesn't work, you can check online for the correct syntax. So you need to install these first on your Python, and then you, what are they calling it? Then you import here. So how do you install this install? For Visual Studio Code, you have what is called the Python terminal. So if you go up here, you'll see terminal, you see new terminal. And when you click new, the terminal allows you to install these things using the command line. For Anaconda and for the regular Python installation, maybe you would have to check if it has an inbuilt command line for the Anaconda, for the Python, and for the Jupyter Notebook. If there's an inbuilt command line, you can use that. An inbuilt terminal, you can use that. If you don't have that, then you would have to use your command prompt. So like for my terminal now, if I say pip install pandas, it should give me a notification that the requirement is already satisfied because I already have it installed. So if I do the same also for NumPy, it will give me that value that the requirement is already satisfied. So I don't need to do that myself. Are you with me? Are you still following? I know the network has been a little bit, but I hope you can still follow.
Yes, sir.
Okay, okay. So the next thing that we are going to do is let us create the data that we want to use. In this case, I'm going to first create a small data for us to easily visualize, but I'm also going to import the data from one of our data sets. So the first thing I'm going to do is I'm going to create a dictionary. I'm going to create a dictionary. And I'm going to call it dict for dictionary, or let me call it my dict, just to be on the safer side. And I'll say my dictionary is equal to, now what a dictionary is, some of these things of course, I'm working with the assumption that we are familiar with some of these things from the first class, but I'm still going to explain some of them to the best that I can so that you'll be on the same page, because I know some of you might have not been in the class that Yinka took. So dictionaries in Python, what they do is, in dictionaries, you can have two elements. You can have a field and you can have the value for that field. Usually in dictionary, if I want to create a dictionary, okay, let me start with arrays. If I want to create an array of numbers, the numbers can just be 1, 2, 3, 4. All right, those 4 elements can be in my array. But if I'm talking about a dictionary, I can assign each of those numbers to a specific key. So I can say first is 1, second is 2, third is 3, and fourth is 4. So more or less, they serve as field headers or maybe column headers that you use in your table. That's one of the closest examples that I can use for a dictionary. So in this case, I'm going to define 3 things. Let me call the first one first score. And if I call first score, I can say that, okay, under first score, I have 100, I have 90, I have 0, and I have 95. That's for my first score. Then I can put a comma and enter second score, which will be the field of my second dictionary item. After that, I put a column. Make sure that the dictionary items that you are typing are in quotations, then a column after the quotations. Then I can put the elements for the second score. I can put 30, I can put 45, I can put 56, and I can put 0. I'm going to replace these zeros with something else later on. So let's just be mindful of that. Then I can put the third score also in quotations, followed by a colon. Then I can, in my third score, inside square brackets, I can put 0, I can put 40, I can put 80, and I can put 98. Okay. So when I have this, I'm just going to type my dict so that I want Python to show me the dictionary when I'm done. So I'm going to run this in Jupyter, and you can see the output we have. We have the first score, the elements are 100, 90, 0, 95. Second score, 30, 45, 56, 0. And third score, 0, 40, 80, and 98. Now, if you are looking at this in terms of data, 0 is not a value that is wrong. Maybe it's not something that you view that is wrong, because there are some elements that can take 0 as a value. Maybe if it's if you're dealing with quantity and there's nothing there, you can put 0 to represent it. But when you are dealing with age, when you see 0, you know that, okay, there is a number that is called 0. You can't have age that is 0. It means the person is not born. And in that case, you know that, okay, there's a problem. So I'm going to do the same thing, but I'm going to replace zeros with what is called nan, not a number that I talked about earlier. And the function for that is mp.nan. So I'm going to replace all of them with all the zeros with mp.nan, because most of the times your missing data will show nan. mp.nan. Okay, so let me run this again. And now instead of the zeros, we now have nan representing the zeros. So in this case, nan means the data is missing. Now, let me use pandas a function called data frame. So let me call it small df, small data frame, is equal to, now the pandas data frame, usually when you have a list, it creates a data frame from the list, such that when you are treating that list, you are treating it as a data set. And so it makes manipulation of that data set easy. You can manipulate based on the headings, you can filter, and you can do many things. It's very powerful. So the function is called data frame. The D and F are capitals, and then it takes an argument inside brackets. So in this case, the argument that data frame will take would be the dictionary that we've defined here, my dict. What we are saying is we want to create a data frame from my dict. But as you can see, the data frame is highlighted in yellow, meaning there's a problem. We cannot use data frame directly because data frame is a pandas function. It is not a standard Python function. It is a function under the pandas library. So we have to specify that data frame is from pandas. So normally how you specify is you write pandas dot signifying that. But remember, I told you that pandas is our university, and we don't deal with the university, we deal with a representative of the university. And we've already assigned a representative, which is PD. And so in this case, it will be pd.dataframe. And when you run this, let me also write out small df so that we can see it after running. We can see what is there. And now you can see that the format has changed. Earlier, we had a format that came out in brackets, but now we have a format that looks like a standard data table. So that's how data frame, one of the things, data frame is powerful. Now, if you want to do data cleaning, one of the major things that you need to look at is you need to see whether the data, whether there are elements in the data that are missing. You want to see whether you have problems in the data. Now, like we had 769 elements with the PIMA database. How do you start going through 769 elements? 769 is even small. When you have data in the tens or hundreds of thousands, you cannot go through everything. So luckily, there is a Python code that can help with that. Sorry, I'm supposed to put the code here. There's a Python code that can help with that, and that function is null. So the is null is under the data frame. So we can say small df dot is null, and we can run this. And what it would show you is all the elements that are null and all the elements that are not null. So if the element is null, meaning there's nothing there, meaning it is none, it will show true, like we have here. But if the element is not null, then it will show false. And now this gives you a sense of direction on how to address some of these things. Are you still with me?
Yes, sir.
Okay.
Yes, sir.
Okay. Okay. Now, another thing that we can do is we created is null for our small data. Let us use one of the data sets that we had, because if you have data, you're not going to be creating it from scratch. You're going to be importing that data set. So one of the data sets we opened was employees. So let us read it. So instead of the first one, I called it what? My dict. That's my dictionary. Let me call this one my data. My data, and say it is equal to, now there's a function called read underscore CSV. The employees file that we have is in CSV format, comma separate variables. You know, Excel, you can save it as XLS, XLSX, or CSV. So we have this thing in CSV format. If you have another format, then you have to look for the appropriate function to read that format if it's available. So, but for the CSV, it's read underscore CSV, and inside here you put the name of the document that you want to read in quotations, in single quotes. But you have to make sure that the document is in that same library. If not, you have to put in that same directory, because our CSV is in the same file as this Python, this Jupyter code. If not, you have to put the complete directory, C users, this, where it's located. So let me put employees here, employees.csv. But in this case now, I still, because it's a pandas library, not a Python library, I have to put my PD dot to make sure that it is done properly. And when it does that, let me try and see, let me type out my data and see if it would come out. Yes, so you can see that we have the data out here. Let me maximize this, and you can see how it is, but it cannot show everything. So it will show usually the first 5 and the last 5 and put ... in between, but it will tell you at the end how many rows and how many columns you are dealing with. So in that case, you are dealing with that data format. Okay, so now that we've read it, let us try our is null on our data. Now, let me call this, what should I even call it? You know, you can name your variables, everything. So let me call this null checker. We want to null check. We want to check if something is null. And we can say PD, which is our pandas. Then we can use the is null. And remember, inside the is null, as we stated earlier, we put, it's either we use the data frame or we put the name of the data inside. And so we'll put the name of our data. What is it called? My data, Abby. My data, yes. So we'll put the name of the data and call it my data. And we can run this. Okay, so all we did was we assigned it to a null check. So I want it to display the values that are null, right? What I want to do in this case is, if you look at this table, when we used is null, it showed everything. And if the thing is null, it will show true. If it's not null, it will show false. Now what I want to do is I want only the elements of my data that contain null values to be displayed. So I have assigned the is null data types to null check. The trues and the falses all go to null check. So now I will use the null check to filter my data. And I'll say my data, and I'll put null check. So in this case, when I run this, it will now show me the data elements that contain none values. And basically what it says is, out of all the data, 1,000 rows have null value. data based on only gender and see which of the gender values have null values. Now what you have is it is only showing which gender values have null value. I think if I make it halfway, I think people tend to see better on the mobile devices. So let me try and see if I can make this a bit better. So it's only showing the genders that have null values, none. So 20 has none, 22 has none, 27 has none, 145 out of all of them have none. So this is another way to check individual columns to see which ones have null values. So it would help you if you are trying to see, okay, among the data, which column has null values that I need to replace. So this is one way to go about it. Now, just like you have is null, you also have another function called not null. So our small df dot not null, and when we run this, it will show everything, but this is now reverse. You are looking for those that are not null. So anyone that is not null will show true, but anyone that is null will show false. So that is another function that you can use for not null. And you can also do the same for the gender that we're talking about. Instead of using is null, you can use not null. Let's copy this and just, and paste here and use not null instead of is null. And when you use not null and you run this, it will show the gender values that are not null. In that other case, you are looking for those that are null. Here, you are looking for those that are not null. And when you add the number of rows of the first one and the other one, it should give you the total number of the data set. So are you still with me?
Yes, sir.
Okay. So now that we've been able to identify some of them that are missing, let's try just one or two operations to see if we can replace some of these non-values. So one function that you can use to replace the non-values is you can replace them with 0. And one of the functions is fill NA. So you have small df dot fill NA and you put 0 inside. And now this should replace the non-values with 0. So let us run this. And as you can see, our non-values here are not none anymore. They have been replaced with 0. So instead of having none, because none would bring problems for you during the machine learning process, you can replace these non-values with 0. And they can, now the network will train, or the model will train better with 0 values instead of none values. Then there is another method that we can use. Okay, so our small df is here. Here we just replaced it. So there is another method we can use called pad. So remember small df is the data frame we created, dot fill NA, that is we're filling the not and numbers, but instead of using 0 to replace it with 0, we are going to put method is equal to pad. Now what pad does is it replaces the non-value with the number that was before it. So let me run this and we'll see. you will see that our first NaN value was this one, the first two. Okay, before this, let me do this so that we can do a comparison. Let me run this. So you can see that our first NaN here was replaced with 90 here. And why it was replaced with 90 was because the number before it is 90, so it was replaced with 90. Our other NaN that is down here, if we look here, it was replaced with 56. And why it was replaced with 56 was because the number before it was 56. And this NaN that is here now, you can see that here it is still NaN because there is no number before it that it can replicate there. So that is why it still remains as it is, as NaN. So if you have a situation like this, you can replace it with the number after it instead of the number before it. And if you want to replace with the number after it, you still do small df dot fill NA, but in this case, the method you will be using is bf fill. bfill. Okay, it's bfill. Sorry, it's bfill. So when you run this, you will see that now this one, it replaces it with the number after it. So our first NaN here was replaced with the 95, which was after it. Our top NaN here was replaced with 40, which was after it. But our last NaN here doesn't have anything after, so it is still NaN over here. So these are some of the operations that you can use to replace some of these values. Are you still with me?
Yes,
Yes,
we are
sir.
hearing you.
Okay.
Yes, sir.
So another thing you can do is, okay, in this case, we are replacing some of these values with from the data frame that we created. What if we want to do it from the data set that we have imported? In that case, what you could do is, remember our data is called my data. And let's say we want to look at the gender column. It is square brackets, be mindful. We want to look at the gender column. Now inside the gender column, we want to fill the NaN values that we have there, that we checked. We had about 145. So what we could do is we can still use the fill NA, right? But in the fill LA now, we would specify what we want those NaNs to be filled with. If we have a gender that is NaN, let us just fill it with something like, maybe let's say no gender, for instance, no gender. Then we need to add an argument for it to be in place, which is true. It's just part of the Python syntax. And when I run this, oh, okay, I have to, let me type my data at the end so that it will show what I did afterwards. And don't worry, I'll give you this notebook afterwards. You can play around with it and the data set as well, however you want, if I'm maybe too fast because of time. So what we did here now, you can see like this gender here is no gender, it's not NaN anymore. So what it did was all the places that had NaN on that gender, it was replaced with no gender. So that's one way to go about it. You can also, what are they calling it? Use a function called replace. You can also use a function called replace. If you go to my data, and we can say my data.replace, then it takes an argument. So what this does is in the entirety of the data, you now are going to replace any value that you see. You put the value that you want to replace and you put the value that you want to replace it with. So the value we want to replace is usually to replace 2 underscore replace, and the value that we want to replace afterwards is called value. So to replace, what we want to replace is we want to replace anywhere we have none, not a number. So we will call it mp.none. That was what we used earlier, the numpy command to represent none values. You cannot just put none there because Python will now take it as a string, none, N-A-N, it will take it like that. It will not take it to mean it means, okay, where you don't have a number. And the value, let's put minus 99, for instance. So what we are saying is anywhere we see none, we want to replace it with minus 99. We can run this. And now here, okay. Let us see. Let me see if I can find any minus 99 in the data that we've not, because the other time we replaced for gender. So where we have, sorry, where we have no gender is still there. So let's look for another empty variable. Okay, we have minus 99 here. So it means before it was none showing there, but it's not under gender, so that's why it remained as none. The only nuns we changed earlier were under gender. So you can use this replace to replace things in your data set. Now, the last thing that I want us to look at, because of time, is interpolate. Remember when I told you about missing data, I told you can either drop it, you can use the drop function to drop the entire row. You can either replace it, which I showed you how to do. So let's look at interpolation. Maybe you have values that you don't know how to, you're not sure of what to put there. They are numerical values. You can just interpolate. What interpolate means is you have numbers and you have a set of numbers, you have empty spaces in those numbers, and you want to use that set of numbers that you have to, what are they calling it, to fill in those empty spaces. So let us try that with our, what are they calling it, with our data frame that we collected. So let's look at, we called it small df. Small df. When I run this, so we have some of the non-values still available. So what I would want to do is I want to interpolate. So what I could do is I can say small df dot interpolate. Now interpolate will generate numbers for these non-values. The interpolation, I have to specify the method. So let us just use linear, which is one of the most common methods to use. And you also need to specify a limit direction, how you want to interpolate it. And we'll specify forward. And when we run this, we can now see that our numbers, like where we had none now, it interpolated between 90 and 95 and gave us a value of 92.5. Where we had 56, it interpolated between 56 and the end, and it gave us 56. But because we specified a forward direction, there was no number before this none that it would interpolate for. And so that's why it remained as none. So is that clear?
Yes, sir.
Okay, okay. So one more thing that I want us to look at is dropping the row or the column. The row primarily. So if you have missing data and you feel that the missing data are insignificant and you just want to drop them, remove them from the data set, you can also do that automatically with Python. And more or less what you would do is, so if we look at our small df and we run that, we still have none values. We have 3 rows that have none values. So what we can do is just say small df dot drop na, and in the .drop NA, it will drop those that have no number. And when you run this, you should be left with only one column, one row, because that's the only row that does not have non-values. So I will stop here for today. I don't know if we have any questions. Let me save the notebook. I will send it to the chat box now, but I will also send it to Mr. Teslim as well. And we can distribute it to us so that we can play around with it. And you can also, a thing about programming is it is not exhaustive. There are many functions that you can play around with for data cleaning. So you can search online for some of these functions so that you can play around with them yourself and see how they work. So do you have any questions?
الصلاة والسلام على رسول الله وعلى آله وصحبه أجمعين. سبحان الله